Swayam Prabha. Digital India. Educated India.
Good morning. Welcome you again in the second week lecture. Last week we have learned to identify the soil type based on grain size and all, and we have learned also to classify the soil. And if we can classify the soil, we will be able to tell the qualitatively the different characteristics of the soil. And now we will try to go one by one to quantify them, and for that first lesson we will try to discuss in this session, that is three-phase diagram and weight volume relationship. Typically if I take a mass of soil and microscopically if you see, you will see something like this inside the grain, and there is a voids, and voids can be filled up with air or water, and there will be third part is solid. And if you can ideally separate them, void is separate volume and solid is separate volume, and then if you can imagine, this is the total volume of voids and this is actually total volume of this is total volume of this is a total volume of solid, and this is total volume. The entire volume is total, suppose in this mass, and then if you separate all voids, then this is the volume for voids and this is the volume for your solid, and then this is the one. Then you can see that we can define a term, that is void ratio, which is denoted as E, and that the definition is volume of voids divided by volume of solids. It is equal to VV by Vs, and this VV by Vs, what could be the range of void ratios or values? You can see, you can imagine that the solid portion is very close to 0 in a mass, then the ratio becomes close to 0, and you can imagine also that void portion is very close to 0 or entire mass is voidless, then your solidless, and entire volume is the by voids only. In that case, void by 0, that becomes infinity. So theoretically this range can be 0 to infinity. And then similarly we can define another term, that is porosity, which is also denoted as N, which is equal to volume of voids divided by total volume, and this value volume of voids by total volume, which is VV by V, and this again there is a porosity and void ratio, there is a definite relationship. We can see here VV is kept as it is, and V can be written as VV plus Vs, and now if I divide by Vs both from here and here, then VV by Vs become E, and VV by VV become 1, VV by Vs equal to E, and Vs by VV, sorry, so VB by Vs become VB by Vs become E. So, this one, and Vs by Vs equal to 1 and VB by Vs equal to E. So, that N to E relationship N equal to E by 1 plus E. So, and what is the what is its what is the range of values of this? Its value actually you can imagine VB by V, that means if it is void is close to 0, then this ratio the over total volume becomes 0, and if void become close to total volume, that void solid is very less, then that ratio close to 1. So, that means porosity void ratio range between 0 to infinity any value, that means you will not be surprised if you see any soil has void ratio more than 1, that is no surprise, actually it can happen, many soil can have more than 1 void ratio, whereas porosity, the value of porosity, it cannot be more than 1, it should be ranging between 0 and 1. And the specific gravity of then another term is that is very important in soil mechanics, that is specific gravity of solid. We can know the mass, but soil grades, what is the specific gravity? The specific gravity of a material is the ratio of the weight or mass of a volume of the material to the weight or mass of an equal volume of water. In soil mechanics, the most important specific gravity is that of the actual soil grain and is given by GS, and from the above definition it is seen that for a soil sample with volume of solids Vs and weight of solids equal to Ws, your GS will become Ws by Vs gamma W. So, that means this is the one, Ws is the weight of solid and equal volume of water weight. So, Vs, that is Vs into gamma W, the solid weight actually occupied by the solid only, because a void that does not have any weight. So, that volume of solid into water, that means equal volume of water, this ratio is the by definition is specific gravity, and that is also can be in terms of mass if you write mass by Vs into rho s. And rho W is 1 gram per centimeter cube, and your 1 megagram per meter cube, either way it can be. So, this is known value, this water density unit weight or mass density for water is known, and specific gravity of most soil, this is the definition we have given, but specific gravity of the most of the soil generally ranging between 2.6 to 2.75, and most of the time for solving any numerical problem, if specific gravity is not given, so automatically one can assume the specific gravity as 2.6 to 7 in between any value for 2.65 or 2.7. And obviously there is a gamma and rho, there is a relationship. Gamma will be rho times g, that where g is the acceleration due to gravity, the value is 9.81 meter per second square. And now I have shown in the previous diagram only two phase diagram, because only I have considered voids only and we have considered solid. But if I consider void is completely dry, then this is the diagram we can think of. This is the diagram we can think of. that is dry condition, only air and only solid, and if all the voids filled up with water, that means saturated, then I can think of this is the diagram, that means this is the volume of water and this is the volume of solid. So, these are actually two phase diagram which I have discussed previous slide. Now, this one actually in most soil will be there in a three phase form, that means it will have partly occupied by air, partly occupied by water and partly occupied by solid, and they are given the symbol like this. V, volume of void, total volume of void is shown here. Out of total void, volume of air given here, volume of water is given here, and volume of solid is given here, and this is actually total volume V. And now based on this three phase diagram, we can define a few more terms, that is degree of saturation. Total volume of voids are they known, but now what percentage of volume is occupied or filled up by water, that actually we denote by using a term, that is degree of saturation, that is SR, which is equal to volume of water by volume of voids. So, volume of water I have denoted previous slides by VV, and we have void I have denoted VW, and total void I have denoted as VV. So, this ratio is degree of saturation. Now, this what will be the range of degree of saturation? Degree of saturation can be from 0 to 100%, mainly because it can be completely dry. In that case, VW will be 0 and VW by VV, that becomes 0, and if it is completely saturated, that means VW become this is VV. So, that ratio become 1 means 100%, and degree of saturation is 100% for completely saturated soil. And now, the density is definition of density. Density is mass by volume, and the unit will be kg per meter cube, and unit weight gamma, actually it is weight by volume, that is W by V, and unit weight will be kilonewton per meter cube. And these are the things actually very carefully one has to keep in mind, that mass and unit weight is just a multiplication of multiplied by G only. And density of water, it is known generally to be assumed, or it is known for any calculation. This is 100 it is 100 kg per meter cube, and weight of 100 kg mass is 109.1 Newton. Hence, unit weight of water is 9.81 kilonewton per meter cube. So, most of the calculation or civil engineering calculation, instead of using 9.81 kilonewton per meter cube as unit weight of water, sometimes we take 10, but if you want to do actual calculation, then it is better to use 9.81, but for simplification, if you want to do, then we can use unit weight of water as 10. And so, these are the things to be remembered, that unit weight of soil, most soil, what will be the value actually. If it is kept expressed in kilonewton per meter cube, most soil will have unit weight between 13, 14 to 20, 21, 22 kilonewton meter cube. An average value of unit weight of soil, mostly it is 16, 17, 18 like that kilonewton per meter cube. Now, bulk unit weight of water, actually we bulk unit weight, as I have mentioned before, that it is total weight divided by total volume, total bulk weight by total volume, that can get bulk unit weight. But we want to express, we have learned now few terms, that is E, then N, then we have learned SR. So, we will try to express the soil bulk unit weight in terms of those, and if you want to try that, first attempt is here. You can see W by V, and that W can be, since if it is, if you consider also 3-phase diagram, then weight of air will be ignored, then your total weight will become summation of Ws plus Ww, and total volume can be expressed Vs plus Vv. Now this Ws and Ww, Ws can be expressed by Gs Vs gamma W. Gs Vs gamma W is the Ws by definition of specific gravity. Gs gamma W is the weight and volume Vs. So, this become the total weight of the solid, and in fact it is weight of W is nothing but your gamma W into Vw. But if I again use the introduce degree of saturation exactly Vw by Vv, this is S. So, now I can substitute Vw, this Vw I can substitute actually S into Vv. So, that is the thing is done. So, this one Ww is expressed in terms of Vv gamma W into Sr, and now if I divide by Vs, then you can see this become 1, this actually Vv by Vs become E, here actually become Gs, here actually Vv by Vs, then it become E and Sr into C. So, if I take gamma out from here, then it becomes Gs plus Sr into E divided by 1 plus E into gamma W. So, that means bulk unit, if you know that these are the quantities like specific gravity of the soil, if you know, and if you know the degree of saturation, and then void ratio, and then you can find out by this, from this expression you can find out the bulk unit weight of the soil. Sometime bulk unit weight also you can find out, but you want to find out some of the parameter like either void ratio is known or degree of saturation is known. One of them is not known, then we can also find out from this using this equation. And saturated unit weight will be equal to gamma sat, that is saturated weight by total volume, and when it is saturated Sr become 1. When it is fully saturated, it is 100%, then Sr is 1. I have already told the previous slide. So, in that case your this equation can be modified. If I put Sr equal to 1 here, then your equation become gamma sat equal to G plus E by 1 plus E into gamma W. So, this is another equation to be remembered. Gamma bulk when it is partly saturated, gamma bulk when it is and gamma saturated when it is fully saturated. So, two different equations are shown which to be remembered. Next is dry unit weight. Dry unit weight gamma D will be dry weight by total volume, and this is you can put Sr, dry unit weight, actually that means Sr becomes 0. Dry means completely dry, then in that case Sr becomes 0, and if I put in the previous equation was Gs plus Sr into E by 1 plus E into gamma W. In this, if Sr if I put equal to 0, in that case this term becomes 0, and then we have Gs by 1 plus into gamma W, that is the thing given here. Buoyant unit weight, actually that is buoyant unit when it is what it is underwater, that unit weight will be different from that normal unit weight. So, that is actually by definition it is saturated unit weight minus unit weight of water. And if I do that, then you can see saturated unit weight we have derived, this is the equation we have derived, and unit weight of water is this one, and if you subtract this, then buoyant unit weight, it comes G minus 1 by 1 plus E into gamma W. So, this is the one another relationship, weight volume relationship one has to remember. So, gamma buoyant unit weight, sometime it is gamma dash used, sometime gamma buoyant symbol will be used, like the different ways this can be expressed, but their expression is Gs minus 1 by 1 plus E into gamma W. So, all those things, if I know the specific gravity and void ratio, I can find out the buoyant unit weight, or some other way, if this is known, then we can find out the void ratio also whenever necessary from this expression. Relationship between water content, then gamma D, the dry unit weight, and gamma bulk. You can see gamma bulk equal to WW plus WS by V, and gamma D is actually WS by V. And using this, and your water content is definition WW by WS, or WS equal to WW, weight of water, will be equal to water content into weight of solid. And if you substitute this, WW equal to weight of water, weight of water, if you substitute weight of water this by water content into WS in this expression, then you can see this WS can be taken out and V will be taken out, and this will be 1 plus W it is coming, and then gamma D will become WS by V is nothing but dry so this WS by V is nothing but gamma D. So, gamma D will be equal to this gamma D, this become gamma D. So, this gamma D will be equal to gamma bulk divided by 1 plus W. So, this is the formula. That means, if I know the bulk unit weight of the soil, then if I, and water content, then if I want to find out what is the value of dry unit weight, then simply bulk unit weight divided by 1 plus water content. This is the thing. If I do, then I will get the dry unit weight. Or in the other way, if I want to, if I know the dry unit weight and water content, if I want to find out bulk unit weight, then gamma D multiplied by 1 plus water content is the bulk unit weight. So, relationship between void ratio, water content, specific gravity, and degree of saturation. You can see that by definition, your water content is nothing but WW by WS, and WW can be written as VW into gamma W, and WS can be written as VS gamma W GS. Okay, and gamma W get cancelled from here, then it become VW divided by VS GS, and VW can be written into again VW can be written in terms of SR and void ratio. Your SR actually equal to volume of water by volume of void, and then VW can be written as SR into VV. So, this one can be expressed into SR into VV, and if I divide by VS both from here and here, then here actually it become SR by VV by VS. So, SR VV by VS, this is E. So, that become SR into E, and VS by VS become 1. So, SR into E by GS. So, ultimately water content will be equal to S into E divided by GS, and So, you can see the relationship finally SR into E equal to W into GS, and for saturated soil, if that means SR equal to 1, then in that case your for saturated soil your E become E equal to water content into specific gravity, and if it is partially saturated, then degree of saturation multiplied by void ratio will be equal to water content into specific gravity is the relationship. This is another relationship, this is another. So, this is the space. From this actually you can derive by putting SR equal to 1. Now, air content. Air content actually is defined as Na, and which is by definition Va by total volume. That means with respect to total volume, how much volume of air is present. So, you can as we have done that 3-phase diagram, the total V can be expressed in Vs plus Vw plus Va, and this one if I divided by if I divide by Va if I divide by V everywhere, and you can see this side this become 1 Vs by V, Vw by V, and this will become Va by V. So, this is Na, and from here I can take it to here, that means Vs by 1 minus Na equal to Vs by V plus Vw by V. And from there we can further modify 1 minus Na. You can see now 1 minus Na Vs by V already there, and Vw by V, and this Vs by V, Vs actually can be written Ws by actually Vs equal to Ws equal to Vs Gs gamma W. So, if I want to express Vs, then it will be Ws by Gs gamma W. So, Ws by Gs gamma W I have written V. Similarly, Ww is nothing but Vw is nothing but Ww by gamma W. Actually, Vw into gamma W is the Ww. So, Ww weight of water divided by gamma W is Vw. So, this we have converted, and then I can see here Ws by V is a gamma D, and Gs gamma W. Ws by V is gamma D is taken here, and Gs gamma W is here, and here actually again Ww I can express by W into Ws, water content into total solid, by gamma W, and if you further simplify, then you can gamma D by Gs gamma W plus water content into gamma D by gamma W. So, from this if I further if I go, then 1 minus this is A is missing, gamma D into gamma D by gamma W, gamma D by gamma W if I take common, W plus 1 by Gs, and further if I go. So, this is the relationship for your gamma D versus gamma D equal to 1 minus Na, that means wear content, 1 minus Na wear content, Gs that is specific gravity, gamma W that is unit weight of water, 1 plus water content of the soil, Gs is the specific weight of the soil. This is the expression for gamma dry. This is the one number of quantities in soil mechanics we have to calculate time to time. Sometime void ratio is given, you have to find out water content, sometimes water content is given, you have to find out void ratio, sometimes both are given, you have to find out your bulk unit weight or dry unit weight or submerged unit weight. So, we have given one equation actually gamma bulk equal to Gs plus S R into E by 1 plus E into gamma W. This here actually once you have derived S R into E equal to W into G, S R into E equal to W into G. So, if I substitute this, then another equation for bulk unit weight will become 1 plus W into Gs divided by 1 plus E into gamma W. So, this equation we have not derived, but we have derived this equation, we have derived relationship between degree of saturation, void ratio, water content and specific gravity, and if that relationship if I substitute here, then you will get another equation for solving. So, this is by and large different weight volume relationship we have to use in various calculation in soil mechanics. Now, I think we will go to the next topic, maybe with some application of those whatever we have learned so far from the first class. Some application we will do with several problems, and we will take it in the next lecture.